Hello, everyone. I am going to be talking about organizing business logic and asynchronous processing in Ruby applications. So a little bit about myself before we jump in. I'm the CTO at Thanx. We are a San Francisco-based technology startup that focuses on marketing, automation, CRM, and digital experiences for brick-and-mortar businesses. You can reach out to me on github.com/drn, my website at drn.dev, or find me on LinkedIn. I'm always interested in connecting. My background in Ruby, I've been using Ruby and Rails for the better part of a decade, and I thoroughly enjoy Ruby for a lot of its use cases. At Thanx, we also use Ruby. We are using we have a microservice architecture that both uses Ruby on Rails on the back end, as well as Golang. And we're using gRPC for inter-service communication. But a lot of the core logic is still built in Ruby. So diving into our topics, organizing business logic. So some of you may be familiar with service objects. So they are great. It's a great paradigm for encapsulating business logic. A lot of the time they're represented as plain old Ruby objects, so poros. They're single purpose classes, and the way they work is that because they're poros, there's no constraints on what you're able to do, what the public interface looks like. And so this concept is actually very, very powerful, and it addresses a lot of difficulties with fat controllers and business logic that's distributed throughout your code base. But while this concept is great, it has some limitations because it does not have hard constraints. And so some of the problems that may easily arise is that because there's no public interface, it's really difficult to chain service object interfaces together. So when you have various service objects that are single purpose that you want to join together, you either have to have an orchestration layer, you have to implement another paradigm, you have to prescribe to a set of concepts that is unique to your code base and is not contiguous. And there's limited reuse in this. And so one way to address this is this concept called interactors. It's an opinionated framework for business logic encapsulation. You can find this library on github.com/collective-idea/interactor or Ruby gems at Interactor. There's also a Rails plugin, Interactor-Rails. It's a library built by our friends at Collective Idea. These interactors effectively have the same intention as service objects, but they're a very clean and very concise API that encourages reuse and encourages best practices. And so diving into what interactors look like, interactors primarily work with a single context object. So before you see what it looks like, describing what a context object looks like is it contains everything an interactor needs. It contains the data, it contains success, status, failure, and interactors have a single public interface. There is a call class method. And the way you interact with interactors is that instead of having to initialize a new class, because in order to minimize the public interface, there's some logic that changes it from internal to interactors that allows you to just run the interactor name, the class name, .call, pass in your context, and then you can run your logic. We'll walk through an example of that shortly. So quick addition to how you interact with a context is the way you access data or add data to a context is you just do context dot whatever attribute you want dot user equals user, and then you access it later with .user. It's very similar to open structs if anyone's out there that's familiar with that concept. You don't have to predefine what that struct looks like, so it's an open struct because it's flexible. You don't have to define the constraints. You don't have to define the attributes before accessing it or adding that to the data set. The way you represent failure is context.failure ? That's a reserved word for contexts. The way you fail a context is fail bang. The similar interface for success. And so this is a very, very lightweight API. There are a couple additional pieces of functionality that contexts provide that we won't go into here, but you can check out the Interactor README on the GitHub page. So diving into a quick example. This is a contrived example that is also described in the Interactor README, but the sessions controller in general for Rails applications, the create method, it authenticates a given user. In this case, there's an email and password parameter that's passed into the create method of this controller. And this is a basic example. The way this could be refactored using an interactor is by adding this interactor called authenticate user. So this is an example of this interface. So all you do is declare a class, simple Ruby class, include the interactor module, then define this specific method. The only public interface, as you recall, is the call method. You just define the instance method call and then run your logic. And if you see here, the context has an email and password. We delegate those methods, email and password, to context, so that email and password are effectively context.email and context.password, but this is nice syntactical sugar to tell the future developers what is actually expected to be found on the context. And if you use sorbet type checking or yard doc for documentation, that's another way of doing it. But you pass in user.authenticate. So if you recall, this is the same exact logic, user.authenticate here. You pass it in and then you respond with .user.token. You're adding that information onto the context if it's successful. Otherwise, you return the message authenticate user.failure, which is the translatable localized error key. And then what you're able to do is refactor your sessions controller to leverage this interactor. So you call authenticate user with email and password, and then you have the interactor that responds, that has access to the .success method of the context. And from that, you're able to interpret and leverage the results that are in the context that was formed within the interactor. And so this is a contrived example. And you may be asking yourself, is this even better? This is actually more code than it was in the original example. Why not just embed all your logic into the controller? What gives? This doesn't seem better. And so the reason why is because the power of interactors comes when a code base becomes more and more complex. So for example, if you want to layer in the ability to lock out a user after too many login attempts, or sending a lockout email, and the list goes on of use cases that you can extend to the authenticate logic. And instead of embedding all the logic into the body of the controller method, you eventually want to have clean encapsulation of all of this logic. So it's much cleaner to have a dedicated place that's independent from the controller to embed this logic. And what this allows you to do is, in the sessions controller, this interface isn't going to change. It's going to stay as authenticate user. But all the logic that we talked about for locking user out after too many login attempts, sending a lockout email, that will live within the body of the interactor. And so as we discussed earlier, interactors are also supposed to be single use. And so instead of adding the lockout logic and lockout email logic into this, what we can do is leverage this other concept that Interactors provides, which are organizers, that allows you as a developer to effectively tie together independent single-use logic. In this example, it'd be authenticating the user, sending the logout email, and validating the login attempts. Looking at, and one last note before we move on to organizers, this absolutely prevents fat controllers by encapsulating this logic, and it allows for this paradigm to continue to grow with organization. A lot of the time, as Ruby applications get more and more complex, they tend to blow. And this is a way of instilling the best practices of keeping classes small, easy to test, having a discrete public interface, and overall will keep your code a lot more easy to use by future developers and easier to understand. So interactor organizers. So another example is place order. In this use case, we are organizing, we're organizing other interactors, a create order interactor, a charge card interactor, a send thank you interactor. This is a little bit more of a complete example. I'm not going to go into the bodies of each of these specific interactors, but you can tell that with a business logic code flow like this, it's a lot more complex. And so we want to encapsulate each of the discrete parts and organize it through this interface. And despite having a different internal interface, the way you interact with place order is the same way you would interact with a single interactor. So the interactor organizers and the interactors themselves have the same exact public interface. All you do is placeorder.call, pass in your context, and the rest is history. It just naturally flows into the sub-organized interactors with the context, and the context is passed between each of them. There's some logical functionality that the interactor library provides that can help manage the workflow between each of the interactors, but that's documented more in the library. So as business logic grows, you can use this pattern, and it helps instill a philosophy. Talking about the benefits, there's low cognitive load for understanding how to trigger business logic, which means that you can iterate quicker. There's no questions about how to interact with a class because the public interface is just interactor.call. All the classes are the same, and having those constraints actually allows for a lot quicker of a development life cycle. It keeps classes small, easy to understand, easy to test. Enables significant reuse of the single purpose logic without refactoring. And because all of these interactors can automatically be chained and organized together without having to build an orchestration layer or any refactoring, this makes this concept really, really powerful. Even if you didn't intend for a single use class to be reused for another use case in the future, a lot of the time you may find that you need to tie together bits and pieces of the code base together. And if you didn't account for that with a plain old Ruby object, service object, it becomes really, really difficult sometimes. And it just adds costs that you didn't need to pay if you had a very clean, strict API. So extending on our example of orders, this is the top class is place order. That's the same exact thing that we saw. Schedule order is another interactor organizer. So if you can imagine a use case where you have an order that your business requires that the order must be charged before it's placed, and then it must be scheduled out in the future, and your application needs to manage the scheduling. So in this case, we're using the same exact logic in place order and schedule order to create a charge on someone's card. And so in this case, we can reuse that logic. And after that, that's where the schedule order and place order diverges. In schedule order, it enqueues the order for an asynchronous process down the line. Place order goes on to synchronously create order and send the thank you. We'll dig into the asynchronous processing in a second, but the enqueue order interactor, this is just saying that there's a job, an asynchronous job enqueued for later. And then once that job is picked up, it runs the finalize order interactor, which then goes on to finalize the logic that's done in place order. So create order, and then send thank you. And so this, as you can see, there's a lot of reuse in this simple contrived example. Charge card is used in both place order, schedule order. Create order is used in both place order and finalize order, and send thank you is used in place order and finalize order. And so following this and prescribing to this API and these philosophies makes it really, really quick to iterate, especially if your entire code base is leveraging this pattern. And there are other patterns out there. Interactor is just one such library. There are others out there, but I highly recommend if you are building out any sort of Ruby application to encapsulate your code with a concise and strict pattern so that refactoring and orchestration isn't required. So we touched on asynchronous processing, if you remember, enqueue order. There's some logic to enqueue, finalize order for the future. Reasons why you want to implement some asynchronous processing. A lot of the time for a lot of Ruby applications, for example, if you're running on Heroku, they have a default 30-second timeout. And so that amount of time is great for responding to requests, but you can't do any sort of heavy lifting. You probably shouldn't be sending an email. You probably shouldn't be doing any data munging. You probably shouldn't be doing any aggregate processing on synchronous requests. And those heavy workloads, that needs to be done by a lot of applications. And that's where asynchronous processing comes in. There's a ton of different options for asynchronous processing. And this is a hard subset of the libraries that are out there. There's database, there's Redis-based, there's cloud provider specific, there's RabbitMQ, there's Kafka, there's a whole host of other libraries that provides asynchronous processing. So database, it's a relatively legacy pattern now. I don't recommend it. So in this section, we'll talk about some advice for how to select a asynchronous processing library. I believe that because it has relatively low performance, especially depending on the database you're using, but for the most part, it has pretty low performance, you'll quickly start hitting lock contention, and it adds load unnecessarily to the database. And given the simplicity of setting up other asynchronous processing methodologies, I don't recommend it. Delayed job here is a library that was originally extracted from the Shopify code base, but that library honestly is not supported anymore. I believe GitHub used it in the past, but for the most part, most organizations have moved away from database-based queuing systems. Cloud provider specific ones, they are actually very, very robust. There's no management costs, but some of the difficulties come in when trying to test this locally. For example, if you're trying to use SQS locally or Google Cloud PubSub, there are libraries and frameworks like LocalStack that enables you to test locally, but it's not as simple as some of the other solutions out there. it may be great for your use case if you are, your platform is not cloud provider agnostic, but it does create provider lock-in. And sometimes the libraries may not be as robust as the community supported ones. Redis-based message queues are, I think, my go-to. Ignore the title on the side, but Redis-based message queues are, I believe, are my go-to. They're easy to set up. There's good enough performance. There are a couple different libraries out there. Sidekick and Rescue are probably the most popular ones. There are, I would recommend Sidekick over Rescue. We've actually used both at Thanx. Rescue initially. So actually the history was no asynchronous processing, then leveraging a database-based message queue probably back in 2011. That was through Delayed Job. Then we introduced Redis-based message queues. So that was through Rescue. And then once we ran into the performance bottlenecks of Rescue, we ported to Sidekick. And Sidekick is still handling millions and millions of events per day at Thanx. I highly recommend it for startups looking for easy infrastructure to manage. It's very, very simple. I'll walk through a demo of that, but it's very simple to develop locally on this. And it has performance that will last for a long time. I think the latest stat that we had was, since we introduced it a couple of years ago, it's processed billions and billions of jobs. And I think I cut it out of my slides by accident, but going back to RabbitMQ and Kafka, they're actually very robust solutions. The problem lies, and it may not be a problem, but the infrastructure that's required to be managed is a little bit higher. And so while you may need it for your use case, for example, RabbitMQ, if you need a message broker for some kind of pub sub, or for microservices, you can leverage Kafka for event-driven microservice communication. Those might be your go-to solutions. And we're actually, at Thanx, we're introducing Kafka. But they might not be the best case if you just want to hit the ground running with a prototype application, especially if your project or your startup is pretty lean and you're just trying to look for product market fit. So putting it all together, I created this very simple Rails application last night. You can find the source code at drn/rubypk. And let me jump into some code. So we have this, let me maximize this. We have this simple Rails application. So looking over to our routes file to get started, we have just an application that has two endpoints, the root endpoint and the count endpoint. So get root and get count. Looking at the application controller, the root has this method that calls ingest purchases.call, and the count renders the amount of purchases. And what we're going to demonstrate here is how both interactors and asynchronous processing fits together. So let's just walk through the code really quickly. So ingest purchases is an interactor that, let me maximize this, that calls, don't worry about this particular client, but all it does is it returns data about the purchases that I have on my Thanx account. It iterates through each of the purchases, and then it logs a statement with the ID, and then it asynchronously enqueues the job for, sorry about the dog in the background, it asynchronously enqueues that purchase for ingestion later. So jumping over to the ingest purchase worker, again, very, very simple use case. All this does is it delegates that parameter to this ingest purchase interactor. And this ingest purchase interactor all it does is it delegates params to context. So we're passing in params to this interactor, and then it calls the purchase create method. So the standard active record purchase.create, and it does some munging of the data. All it does is everything's the same except for these 4 keys. We're changing it from ID to UID. And then lastly, looking at our schema, it's a very simple schema. All it does is we created a table with purchases that have all those attributes. So what that looks like is on this screen, you have a lot of different tmux windows. So we have here, I'm about to run the Rails server. Here, I'm going to run the Sidekick process. And remember, we have a couple different API endpoints, the /count, the get count endpoint that returns 0, which means that there are 0 purchases. At the top where I'm at right now, top left, we have purchase account. There are no purchases here. And so what we're going to do is hit the API endpoint, curl root. And what this is going to do is you can see all the stuff working. What it did, if you remember, application controller, it hit this ingest purchases, which enqueues all of the purchases. I think there are 10 purchases, and it queues it for asynchronous processing. So that's what happened here. So if you see ingest purchases, and then what Sidekick does, which is the asynchronous Redis-based message queue, it picked up all those classes and it started them and ran them in milliseconds. It's extremely fast. And what happened is now that these, I think 10 or 20 purchases got ingested, you can look at purchase.count. There's 20 purchases. You can look at the last record. That looks good. And then the API endpoint reflects. And then we can continue to do this. So we can continue to, so I have a while loop that's just going to continuously creating purchases. And if you look at, this is the Sidekick interface. This is built into the Sidekick library. It allows you to inspect the active traffic that's going on. And so you can see a lot of activity that's happening here. Let me refresh this. Go to queued live. So it's processing it, but it might be running a little too quickly to actually show up. And let me pause Sidekick. So you could see the queued jobs are building up. It was running a little too quickly. So this is all the data that's being queued. So restarting the Sidekick process, you can look back over to busy, hit live pull. You see that process is running again on my MacBook. And then if it wasn't processing, oh, there it goes. If it wasn't processing too quickly, you could see all the jobs that are active. And if you stop this process, you can now see we now have 2,400 purchases in our system, and it reflects in the API endpoint. And so all this is to demonstrate how simple it is to leverage interactors and leverage Sidekick. The only other dependency for Sidekick is that you need to install Redis, which is as easy as brew install Redis, and then you can brew services, list it, and Reddit homebrew especially makes it dirt simple to manage. So it's started and running in the background always. So the way you do it is just gem Sidekick and then gem Interactor Rails, or if you're not using Rails, gem Interactor. And so it's very, very simple. I highly recommend these patterns, and I hope each of you can apply it to some use case in the future. And tabbing back to our presentation. And that's all I have. And so if anyone in this group has any questions, I'm happy to spend some time answering them. And I'm figuring out how to figure out chat. All right. Live streams, encrypted malloc. Which auth is best, and JWT or passport for Ruby on Rails best compatibility? Which auth is best? I think this is asking about a topic that I didn't cover here, but which authentication method is best? I think they're all different. What we use at Thanx is OAuth 2. We use the Doorkeeper library, and it just is a Ruby implementation of the OAuth 2 spec. For the most part, how we give external parties access to our APIs, as well as internal parties for the power our UIs. We just leverage the authorization code type flow of the OAuth 2 spec that's implemented by Doorkeeper, and we provide access tokens, and then using that access token, users can interact with our API using the authorization bearer header. And that's how we manage authentication. But I didn't have time to talk about it, that particular topic during this meeting, but perhaps that's a future topic. How are interactors different than any other token system? So interactors are not a token system, but perhaps I clarified this looking at our notes. That was from 917. So interactors is a encapsulation, it's a strict API for cleanly encapsulating business logic. Selman asked, do you use Sidekick batch processing at Thanx? Yes, we do. And let me actually pull up what that looks like. So yeah, you can see this is an internal dashboard. We have 4 billion processed jobs since we last reset this. And so we have lots of queues running, and you could just see the activity here. So it's heavily used, and it's our primary workhorse for asynchronous processing. Let's look. How many concurrent connections can it open? So it depends on, so I will say that Redis is very, very highly concurrent. So there are a lot of different hosted Redis options, but effectively you can get, so they say, unlimited connections. We've spiked up to around 2,500, 3,000 workers running on one Redis cluster. So we use Redis Labs. There's also AWS Elasticache. We have not ported over to Elasticache specifically because AWS can be a little bit expensive, and by default, there's no authentication for Elasticache within AWS, and so you need to, if you don't have a platform that's fully isolated within a virtual private cloud or your own platform network, you need to figure out your own authentication system. But it's highly, highly concurrent. Redis, if you're not familiar with it, it's an in-memory data store that's designed to be highly concurrent, but it's actually atomic. So it's implemented in a single threaded way that gives you the ability to have atomic transactions. So you can not only use it for message queuing, but you can use it for like distributed atomic locking. If you want to implement a mutex across different services, you can really easily do that with Redis. And there's concepts like the red lock algorithm based on top of Redis that we also use at Thanx and has been immensely helpful. And I don't think I have any other questions for now, and I'll wait a couple minutes for Sabrina to relay any additional questions. No more questions. Amazing. Okay. Well, I hope that was helpful, everyone. And to close it out, I highly recommend just looking and reading the Interactor README, as well as considering Sidekick for your next asynchronous use case. Thank you, everyone.